Hello, data enthusiasts. Welcome back to the channel. Whether you're a seasoned analyst or just starting your data journey, today's video is going to be a game changer. We're diving into one of the most essential skills in any data professional's toolkit, data manipulation. Think of data manipulation like preparing ingredients for a gourmet meal. Raw data is rarely ready for analysis. It might be messy, incomplete, or structured in a way that doesn't answer your questions. That's where manipulation comes in. It's all about transforming, filtering, and reshaping your data to uncover the insights hiding beneath the surface. In this video, we'll explore how to tackle common tasks like filtering rows and columns, creating new variables, and selecting columns. Alright, let's get set up for today's session. To work our data magic, we'll need two key packages, dplyr and tidyr. Now, if you haven't installed these yet, no worries, we'll cover that in just a moment. For today, I'll be using the tidyr meta package, which is like a treasure chest of tools for data science. It includes not just dplyr and tidyr, but also gems like read are for importing data, librdate for handling dates, and string are for text manipulation. When you load tidyr, you're essentially unlocking all these tools at once. Think of it as your all-access pass to clean, efficient data workflows. But today, we're putting the spotlight on dplyr and tidyr. These two are the dynamic duo of data manipulation, dplyr for transforming and summarizing your data, and tidyr for getting it into the perfect shape. Quick pro tip, if you're new to these packages, just run install.packages tidyr once in your console and you'll have everything you need. Already installed? Fantastic, you're ready to roll? Let's keep things simple and focused. By the end of this video, you'll see why these tools are a data analyst's best friends. Grab your dataset and let's dive into the code. Trust me, once you see what these packages can do, you'll wonder how you ever worked without them. Alright, let's kick things off with a real-world dataset. For today's tutorial, we'll use the flights dataset from the NICFlights 13 package. This dataset is a treasure trove of information about flights departing New York City in 2013, perfect for practicing data manipulation. First, let's load the package. If you haven't installed it yet, no worries, just run install.packages. NICFlights 13. Once in your console. Already have it? Awesome, let's load it up and take a peek at the data. Here's what we're working with. You'll see columns like year, month, and day for flight dates, DEP_time and ARR_time for departure and arrival times, DEP_delay to track delays, and even details like destinations and flight durations. It's like a backstage pass to understanding air travel patterns. Let's get started. First, we'll load the NICFlights 13 library. If you're new to this package, don't worry, it's a goldmine of real-world flight data from New York City in 2013. For those who haven't installed it yet, just run install.packages NICFlights 13 once in your console. Ready? Let's load it up. Now, here's a pro tip. If you're curious about what's inside the flights dataset, R's built-in help function is your best friend. Just type flights and run that line. It'll pull up the official documentation like a user manual for your data. You'll see everything from column descriptions to example usage. Think of it as your cheat sheet for understanding the dataset's structure. Take a moment to skim through this. It'll tell you exactly what each column means, like DEP_delay for departure delays or carrier for airline codes. Trust me, even seasoned analysts use this trick to refresh their memory. Knowledge is power, right? Understanding your data's metadata isn't just smart, it's essential. It saves you time, avoids confusion, and helps you ask sharper questions. So go ahead, explore that documentation. Let's jump into action. We'll start by selecting specific columns from our dataset. To keep things simple, let's focus on the first four columns: year, month, day, and DEP_time. For our dataset flights, we have to pass in a vector of the of number specifying the column position within the square brackets. Watch what happens when we run this line of code. It's like curating a playlist, but for data. Voila! You can see we've isolated just those four columns. But here's the golden rule. When using column index numbers like 1:4, always double-check their positions. Columns are like seats on a plane. If the layout changes, seat 1 might not be where you expect. A quick peek at the dataset structure, using glimpse, flights, or flights, saves you from surprises. Why does this matter? Well, if someone adds or reorders columns later, your code might grab the wrong data. That's why many analysts prefer using column names instead of numbers. It's like using GPS coordinates instead of guessing directions. Now let's level up our column selection game. Instead of relying on index numbers, we can use something even more intuitive, column names. This way, there's no guesswork. It's like calling a friend by their name instead of their seat number at a concert. Here's how it works. Inside the square brackets, we pass a vector of the exact column names we want. Let's try grabbing DEP_delay and ARR_delay, two columns that tell us exactly how late those flights were. Watch what happens when we run this line. And there you go. Just the data we asked for, no extras. This method is gold because it's self-explanatory. Anyone reading your code instantly knows what you're targeting. Plus, it's future-proof. Even if the column order changes, your code stays reliable. Precision is key in data work, right? Time to tackle the next superpower in data manipulation, filtering. Now let's clear up a common question up front. What's the difference between selecting and filtering? Think of it like this. Selecting is about which columns you keep, like picking tools from a toolbox. Filtering is about which rows you keep, like using a searchlight to spotlight exactly what matters. Let's break it down. When you select, you're slicing your dataset vertically, grabbing columns like year or delay. But when you filter, you're slicing horizontally, asking questions like, show me only flights delayed by more than an hour, or give me flights from December. It's all about narrowing down to the rows that meet your criteria. Before we filter, let's quickly revisit our dataset. When we view the flight's data in tabular format, you'll see all the variables we're working with: dates, times, carriers, and more. Today, let's focus on answering a specific question. What do flights operated by American Airlines carrier code AAA look like? To filter for American Airlines, we'll use R's filter function. Here's the game plan. We'll tell R, hey, show me only the rows where the carrier is AA. Let's break it down step by step. Watch this. We start with our filter function, then we pass in our flight's data and specify carrier equals AA. The double equals sign here is crucial. It's how we say exactly matches in R. Then we pipe the result into view to see it in a clean, scrollable table. Let's run this line. And there it is. Only American Airlines flights neatly organized. This is how you turn a giant dataset into a laser-focused snapshot. Notice how the original data stays intact? Filtering doesn't delete rows, it just hides the noise, like putting on noise-canceling headphones for your analysis. Let's try another filtering challenge. This time, we'll hunt for specific delay values. Imagine you're a data detective. Your mission is to find all flights where the departure delay is exactly 2 or 13 minutes. Maybe we're studying oddly specific delays, or perhaps it's just a fun way to practice. Either way, let's crack this case. Here's how it works. We start with our flight's data, pipe it into filter, and use the %in% operator to ask R, show me rows where DEP_delay matches either 2 or 13. Then we pipe the result into view for a clean, scrollable table. Let's run this line. Boom. Only flights with departure delays of exactly 2 or 13 minutes. This is filtering at its finest, slicing data with surgical precision. Notice how the %in% operator acts like a checklist? It's way cleaner than writing multiple or conditions. Efficiency for the win. Your turn. Swap in different delay values, maybe 5 and 42, and see how the results change. The more you experiment, the more intuitive these tools become. Ready to filter like a pro? Let's keep rolling. Time to level up our filtering skills. Let's tackle a slightly more complex challenge, finding flights that meet multiple conditions. Imagine you're planning a study on early morning flights in specific months. We'll filter for flights in January or May, months 1 and 5, and with scheduled departure times before 6 a.m. That's sched_DEP_time less than 600 in 24-hour time. Let's break this down. Here's the magic of logical operators. The and symbol acts like a strict bouncer. It only lets through rows that satisfy both conditions. Think of it as saying, show me flights that are in January/May and depart before dawn. Let's run this and see the results. Only flights that meet both criteria. This is how you uncover hyper-specific patterns, like whether early flights in these months are more punctual. But here's the fun part. Swap out the months or time thresholds and you'll answer entirely new questions. Time to zoom in on subsetting rows. This is like using a microscope to focus on specific observations in your dataset. But first, a quick heads up. When working with square brackets in R, that little comma is your best friend. It tells R, hey, we're focusing on rows here. Let's see how it works with a real-world example. Here's the breakdown. Inside the square brackets, we first specify our condition flights $dep_time equals 517 to find flights with a departure time of exactly 5:17 a.m. Then we add the critical comma to signal that this is a row filter. Without it, R might think you're asking for columns instead. Let's run this line. Boom. Only flights departing at 5:17 a.m. pop up. That comma is like a secret handshake between you and R. It keeps things running smoothly. Think of it as the difference between saying find me flights at gate A1 versus find me gate A1 flights. Precision matters. If you forget the comma, R might throw a confusing error or return unexpected results. When in doubt, double-check your syntax. It's like making sure your GPS has the right address before hitting the road. Ready for another round of row subsetting? Let's level up. This time, we'll search for flights with arrival times at two specific moments, 5:30 a.m. or 10:04 a.m. Think of it like setting up a searchlight to spotlight these exact timestamps. Let's code it step by step. Here's the playbook. We use the symbol that's the logical or operator to tell R, show us flights where arrival time is 530 or 1004. Don't forget that all-important comma to keep her focused on rows. Let's run this and see what we find. Ooh, my bad, I forgot to put in a comma. Success! Only flights landing at exactly 5:30 a.m. or 10:04 a.m. appear. This is how you slice data with surgical precision. Notice how the OR operator broadens our search. It's like casting a wider net to catch exactly what you need. And that's a wrap on today's data adventure. A huge thank you for joining me. Whether you're tuning in for the first time or you've been here since day one, you are what makes this data community so incredible. If you found this helpful, do me a quick favor, smash that subscribe button and ring the bell so you never miss a tutorial. Trust me, we've got even more data magic coming your way. Got questions? Or is there a specific topic you'd love to see us tackle next? Drop it in the comments below. Your ideas fuel this channel and I read every single one. Let's keep the conversation going. After all, data is better when we explore it together. Lastly, if you know someone who's curious about R, data analysis, or just loves turning chaos into clarity, share this video with them. Let's grow this community of data storytellers one spreadsheet at a time.